looking at the certs that we are given, if you want to jump straight into rationalizing by multiplying square root 50 plus square root 48 over square root 50 plus square root 48, if your decision is to do this, you will realize that you are dealing with very large numbers and it's not very ideal. Okay, while it is not wrong, okay, but it may not be the most efficient. Okay, so the better way is to try to simplify each of the certs first. Okay, so square root 18, we know that it is 9 times 2, for which it will simplify to be 3 square root 2. Okay, so as mentioned before, we went for our school holidays, for March holidays. Okay, we know that whenever we want to simplify certs, we need to actually identify all the perfect squares. Okay, so 18 being 9 times 2, square root of 9 is 3, that's why 3 square root 2. Then for square root 12, it is 4 times 3, so we get 2 root 3. Okay, and then square root 50, it is 25 times 2, so we get 5 root 2. And then 48 is actually 16 times 3, so we get 4 root 3. Okay, any problems in doing simplification of the certs? Right, great. Then from here, we go about doing our rationalization, for which we need to multiply by the conjugate. Okay, so 5 root 2 minus 4 root 3, the conjugate itself is 5 root 2 plus 4 root 3. So if you recall, the reason for us to do this is because we want to do our a squared minus b squared in the denominator. For which we have 5 root 2 squared minus 4 root 3 squared. This is ideal because once I square a square root, there's no more square root for us to talk about. Okay, so that's why we multiply by the conjugate, which is the opposite sign. Okay, then in the numerator, we are looking at the expansion or the multiplication of these two expressions. Okay, there we are doing our rainbow method. So 3 root 2 times 5 root 2, 3 times 5, 15, root 2 times root 2 will just be 2. Okay, then 3 root 2 times 4 root 3, that will give us 4 times 3, 12. Root 2 times root 3, that will give us root 6. Okay, how do I get? How come plus? 3 root 2 times 4 root 3, right? Okay, then negative 2 root 3 times 5 root 2, I will get negative 10 root 6. Followed by negative 2 root 3 times 4 root 3, I will get negative 8 times 3.
Wait, you
Sorry. Okay, so we have this, right? Sorry, so in the denominator you can simplify it already. We know that this will give us a whole number. It will give us an integer effect. Okay, so you can just press into a calculator directly. Okay, for the denominator, it should give you an integer. If you don't get an integer, you get a decimal, that means something is not right. Okay, so pressing the calculator, you will get the value of 2 in the denominator. Okay, so 15 times 2 is an integer. We subtract 8 times 3, they are the like terms. So we will get 6. Okay, 12 root 6 minus 10 root 6 will give us positive root 6, positive 2 root 6 divided by 2. Simplifying it, 6 divided by 2 is 3, 2 divided by 2 is 1. So we get 3 plus root 6. Okay, so that's how we do our question 60. Problems? Okay, those who don't have any problems in doing this, I would appreciate if you can mark your own work. Okay, just go and check if it's correct. Okay. Yeah, green pen, pencils. Okay. Next for 7A. we try to simplify it first. Half is 4 times 3. So square root of 4 is 2. So 4 times 2. Okay, then root 3. Minus away 2/3 root 3. And for this fraction, we got to rationalize it by multiplying with root 3 over root 3. Okay, so we get 8 root 3 over here minus 2/3 root 3, followed by minus 18 root 3 over 3. Okay. 18 divided by 3, that's 6. So you can recognize the root 3 like it's an algebraic x. Okay, so it's 8 minus 2/3 minus 6. Key that into your calculator. Right, and then we will get 28 over 3. Okay, so similarly, like our coefficients, usually we don't write it in mixed number. So likewise, we shouldn't have a mixed number over here, write it in improper fractions. Okay? See? 4 root 3 over 3 this answer. Okay, I did something wrong somewhere. 4 8. Oh, sorry, I completed wrongly. Let me just correct myself. Now at this juncture, I thought that it's timely for us to know how do we check our answer. Okay, whenever we have to do simplification like that, how do we check? Type in the calculator, and what are we looking for? Same value. Okay, so to check whether your answer when you simplify up to the end, is it actually correct or not? Okay, it is to have clear understanding about equal sign. Because if I were to say that all these are equal, that means the value is retained throughout every single step. So what you can do is you press into calculator this expression here, see what is the decimal value that you get, and then also press into calculator your final answer over here. Okay, they should be the same. If it's different, that means something is not right in between your steps. Okay, and you have to go searching for a problem lah. Right? So that is the way that you can check our answer. Okay, they should be equal one. If they are not the same, then it doesn't make sense for us to say that it's equal. Okay. Then next 7b. Okay, 7b. We have 4 root 2 over root 2 minus away square root 1 to 8 over 3 plus 2 over root 8. Okay? So same thing, as long as you have the roots in the denominator, you have to do your rationalization. In this case, we multiply by root 2 over root 2. Then for the root 1 to 8, you need to simplify it. 1 to 8 is actually 64 times 2. Okay, if you don't know your complex squares very well, just use your calculator, divide by factors that you know, okay, and then see if there are any repeated factors as well. Okay, so 64 times 2, that will mean that it is 8 root 2, because square root of 8 is 64. Okay, square root of 64 is 8. Then likewise for 2 root 8, we need to multiply with 8 over root 8. Okay, so we will get 4 root 2 here, divided by 2, minus away 8 over 8 root 2 over 3. And in this case, we get 2 root 8 over 8. Okay, that's one way you can do this. Otherwise, your root 8, you may have also noticed that it is 2 root 3. That's also fine. Okay, so 4 divided by 2 is 2, root 2. 8 over 3 root 2 here. And then this is 2 times 2 root 3. Yeah, 8 is 4 times 2, so it is 2 root 3. I just didn't do it at the front, I did at the back. Yeah, give me the same thing. 8 4 times 4. Okay, so then after that you will get 2 root 2 minus 8 over 3 root 2 plus 4 divided by 8, that is half. Okay, then you press calculator, 2 minus 8 over 3 plus half. And you will get negative 1 over 6. Okay. Yeah. Now, Jovan is asking whether if you write negative root 2 over 6 acceptable or not. They mean the same thing, huh? Okay, they mean the same thing, right? It's just that this is negative 1 over 6 times root 2, which is root 2 over 1. So numerator times numerator, denominator times 2. Okay, so understanding your notations. Yeah, exactly same thing. Yeah, exact same representations. Okay, so 7b is done. Next, 8a. After going through so a few questions already, can I just understand what is the struggle in doing these questions? What's the problem that we encounter? The simplification process. Oh yes.
For every step, I must always simplify.
Yes. Yeah, you got to simplify our answers. Okay. So you see the simplification process that we are finding it challenging. Okay, so that's why it's very important for us to recognize our perfect squares. Okay, and you can rely on a calculator for that. Okay, knowing our numbers like 1 to 8. Okay, what is the perfect square times a certain number? Okay, so try to use your calculator to do this. So you can do your side working. Okay, if you are not that great at that yet. Okay, so 1 to 8. I will usually do as divided by 4 first. Okay, so 1 to 8 divided by 4, you will get, using your calculator, 32, right? Okay, for which 32, I know that there's still some more perfect square inside it. Okay, 4 times 8, and then 8. Okay, it's 4 times 2. So I know that 4 times 4 times 4, that will give us 64. Okay, and 64 is a perfect square. Okay, so two small numbers. Okay, small perfect squares to find it more manageable. Rather than tackle your 25, 64, 49. Okay, but 49 is unique lah because that's 7 square. Okay, so doing smaller ones, okay, for even numbers will be easier and more manageable. Okay, so let's look at A. For AA, we have to do each fraction individually. Okay, so 1 over 4 root 3 minus 2 times 4 root 3 plus 2. Okay, then minus away 2 4 root 3 plus 2. Then multiply by 4 root 3 minus 2 over 4 root 3 minus 6. Right? So in our denominator, we are getting 4 root 3 square minus 2 square. Numerator, we have this. Over here, same thing. 4 root 3 square minus 2 square. Numerator will be 2 4 root 3 minus 2. Okay? So in the denominator, use your calculator numerator, expect an integer. Okay, we will get 44. In this numerator, expand it, we get 8 root 3 minus 4. Keep in mind that the minus sign stays outside of the fraction. We are not bringing it into our expansion. Okay, so since the denominator is the same, we can subtract, okay, the numerator, but this is where we need to be very careful when I combine it into a single fraction. It is essentially 4 root 3 plus 2 minus away 8 root 3 minus 4 as a whole together. So there should be brackets. Okay? One common mistake that tends to be made is that you don't put the brackets. Okay? And then this remains as a minus 4. Because when you put brackets, you remember that opening up the brackets is opening up the brackets will give you a plus 4 because minus and minus gives you a plus. Okay, so that tends to be the trap that you tend to fall into. Okay, when simplifying. Okay, then 4 minus 8 is negative 4, 3, 2 plus 4, that's 6. This can still be simplified further by dividing by 2 in the numerator and denominator because there's a common factor of 2. So this will be the answer. Okay? This negative sign remains in the numerator. It is not outside the fraction. Okay? Questions? Okay. You rationalize this one. Okay, so this one I keep it first. Okay, so we multiply by what? 5 root 2 plus 2 root 3. Okay, so we should be multiplying this, right? Okay, then for this side, if you want to, you could expand it really. Up to you. Yes, Jaden.
Can you still put the equal sign to be like times the thing if you rationalize the
okay, so that's a good question. Okay, so from here to here, can we still put equal sign? The answer is yes. Because when I multiply this, right, what value does this hold? It's a multiplication of 1. Okay, so the value doesn't change. Right, so that's why it is equal. Okay, and that's why at the end we can compare whether this value and this value they are the same or not. Like you say, I'm not right? So continuing, so if you want to, you can expand this concurrently as you do that. So square root 6 times 4 root 2, that will give you 4 root 12. 6 times 2 is 12. Root 6 times 3 root 3, that will give you 3 root 18. Right? Then over here, 38 times 5 root 2 plus 2 root 3 over 5 root 2 square minus 2 root 3 square. Okay. Then you can press the calculator for this denominator. 4 root 12. 12 is 4 times 3, so that is 2 root 3. 18 is 9 times Then 76. Denominator will be 38.
Actually, we just cancel the 38.
Yes. Okay. Yeah. So actually, if denominator is not equal to 38, you can just cancel with the 38. Yeah, correct. Okay. So this one simplifies to 8 root 3 plus 9 root 2 minus away. In this case, if you cancel away, take out down as a minus sign, so you'll be left with 5 root 2 plus 2 root 3. Okay, the brackets over here are important because it will impact the operation inside the brackets. Okay, so we will get 8 root 3 plus 9 root 2 minus 5 root 2 minus 2 root 3. Right, and then it simplifies to 14 root 3 brackets plus 4 root 2. Questions? Yes. Wrong. Sorry? Okay, wait what did I talk about? Oh, I calculated wrongly. 8 minus 6. Yes. I had a mistake. Alright. Any problems? 11A. Okay, we have 3 minus root 3 square minus 5 over 2 minus root 3. What to do? Isaac now. What will you do first?
Identity for like apply the identity for the 3 minus.
Okay, good. So what do you get?
3 square minus 6 3 plus 3
Plus 3, okay. Just in case people don't understand how you apply identity, I write down the steps. Okay, so what Isaac is saying is that he recognized the A minus B bracket square here. So this is your A square minus 2AB plus B square. Okay? Alternatively, of course, you can see as repeated multiplication and then do your rainbow method. Right? Then, Isaac will continue. What will you do for the right side?
rationalize
Rationalize, and what do we multiply with?
sine plus 5 over
8 root 3, right?
3 sorry
Okay, great. Okay, so we rationalize the one that's in the fraction. Okay, then it is about simplifying already. This is 9 plus 3, 12. Minus 3, 1. Okay, so well, this is divided by 1. When you remove the denominator, careful, there's a minus sign outside. So actually it is referring to 12 minus 6 root 3 minus away 10 plus 5 root 3. So you notice that in all the problems that we have just been doing, we always encounter this problem whereby you must have the minus sign with the brackets. operation that's found inside the brackets. Okay? So that might be a reason why you're not getting the answer. Okay? So 12 minus 10 is 2. Negative 6, negative 5, that's negative 11. Okay? So this will be the answer. Okay? Okay, we look at 12b. So that's the question found in your textbook, page 58. If you want to read it. It says that the triangle ABC is such that its area is 3 plus root 15 cm squared. So this is what we're given. And then it says that the height of AB, or rather height AB, is root 5 minus root 3 cm. And they later on said that angle ABC is 90 degrees. We want to find the length of BC. Okay? And BC is of the form P square root 5 plus Q root 3. Okay? If you were to read the question in this manner, okay, you will definitely find it challenging for you to think of how to solve for BC. You need to draw a diagram to understand this question. If without a diagram, I will find it's near impossible okay, to figure out what to even do. Right? So they say that angle ABC is 90 degrees. So surely what kind of triangle are we expecting? Right angle triangle, right? So draw a right angle triangle. Doesn't matter how it looks like, so long as triangle can be. Okay? And it says angle ABC. So A must be here, B must be here, C must be here. Okay? Then after that, they gave you area to be 3 plus root 15. And then length of AB is here in my diagram. That is square root 5 minus square root 3. I hear that you think of right angle triangles and you relate it to Pythagoras theorem. It doesn't apply. Pythagoras theorem doesn't apply in this case because Pythagoras theorem is lacking on 3 sides. Down here you only got 1 side and you're given area. Okay, we want to find BC. So what we need to do is just use the area formula of a triangle. Half times base times height. Since down here 90 degrees, your base must be BC, your height will be AB. Okay? So that's how you form the equation. Okay? So half times BC times the height, making sure there's brackets around the height because it is an expression altogether. That will be equals to 3 plus root 15. Okay? Our objective is to find out what is BC. So we divide over our half. We also divide the square root 5 minus square root 3 over to the right side. Dividing by half will mean multiplication of 2. Followed by dividing by the root 5 minus root 3. So this is your BC. Okay? Question wants it to be of a specific form. And that is after rationalizing. Okay? So from here you rationalize it. So 2 times 3 is 6. You may want to simplify your square root 15 first to make things easier later on. Anyway, square root 15 no way to simplify. There's no perfect square inside. So then we multiply by root 5 plus root 3 over root 5 plus root 3. Okay? I think I've done enough rationalization already, so I trust that you can do this. Okay? Yeah. Inside. Otherwise, you're looking at 419. Then usually simplified form is yeah. If you Square root of 9. Oh, no, that's not simplified. I've got a lot of combinations. You get 15. Why you choose 9? Yeah, but 3x are outside, not outside. So 9 times 15 divided by 9. 15 divided by 9. 5 over 3. To get is 15, is it? We do integers inside. Okay, so that one I leave it to you. BC, the answer that you should get is 6 root 5 plus 8 root 3. Okay, question only asks you to find out the expression. They did not ask you to state what is P and what is Q. So you just have to leave your answer like that. You do not need to write down P equals to 6, Q equals to 3. Okay. Last one, exercise 3.1. Okay, test you on your cones. What's the formula for cones? Then Google. Okay. So these are common questions that are asked in your certs. Okay. For volume of cones, pyramids as well. Okay, so these formulas are not given in your formula list. You need to be familiar with them. In your Emacs formula list, yes. But your Emacs formula list, no. Okay. So question 13. Let's understand the question first. It says a right circular cone. Okay. What does it mean by right? It means that it is upright. There's no such thing as left circular cone. It is not trying to say that your circular cone is on the left, on the right side of your paper. No. Right circular cone just simply means that it is upright. Okay. So based on how we did our earlier question, you may draw a cone as well. Okay. It is upright whereby the center of the base is aligned with the vertex of the cone. Okay. So it says that the height is 2 root 3 minus root 2. Okay. And then the slant height, in case you've forgotten what is the slant height is the edge over here. It is given to be L. Okay. Volume of the cone is given to be root 18 plus root 48. Not forgetting there is hidden pi there. CM2. Question said no using our calculator. Okay. We want to express L squared into a third form, meaning to say an exact form, like that, where A and B are integers. Okay? This information about A and B are being integers is quite helpful because sometimes, okay, if you end up getting rational numbers as your answer, okay, for A and B, that tells you that something must be wrong somewhere. Okay, so keeping in note on the fact that A and B must be integers is helpful for checking. Right? So how to solve this question? There's many layers to it. Okay. First of all, what's the formula for volume of cone? 1/3 pi r squared height, right? Okay. In this question, is radius given to us? No. So we need to figure out what is the radius. So I define R to be the radius. Okay. So using my volume of cone formula, okay, 1/3 times pi r squared times the height, which is 2 root 3 minus root 2, will have to be equals to root 18 plus root 48 pi. So I can form this equation here. Okay. Please don't go and press your calculator and try to compute what is pi times all this, because we want to use to get exact form. Okay, question also says no use of calculator. These are all multiplication. Okay, on the left side and on the right side. I can divide on both sides by pi, such that my pi gets eliminated. Okay, so the pi actually addresses itself. So I'm going to get 1/3 r squared 4 root 3 minus root 2 equals to root 18 plus root 48. You may wish to simplify your root 18 and root 48. 18 is 9 times 2. So square root of 9 is 3. So we get 3 root 2. And then 48, you can get 16, is it? Times 3 is. So that will give us 4 root 3. Okay? So then I can find out what is r squared by dividing 1/3 over, so that is multiplication of 3. And then dividing this expression, the height, over, and we get this. Okay? Now, if your decision is to go and find out what is r exactly, that will require you to take square root. And that will become very messy for you. Okay? If you want to go and find r, and then you go and take a massive square root over all the little certs that you already have, okay? That will give you a massive headache. Looking at this, I also get a headache. Okay? It is not efficient. Right? Because what is the objective? The question wants you to find L squared. Not trying to ask for L. So actually, later on, notice that there is a right angle triangle found inside your cone. That is where we can apply our Pythagoras theorem. Okay? Whereby r squared plus this thing squared is equals to L squared. So in order to find out what is L squared, do I need to know what is r exactly? I don't. I am contented with just r squared. So no need to go and do this extra square root. Okay? Yes, just go and simplify this part first. So to simplify it, let me just expand the numerator first. I will get 9 root 2 plus 12 root 3 over 2 root 3 minus root 2. And then we get 9 root 2 plus 12 root 3 root 3 plus root 2 over 2 root 3 square minus root 2 square. Denominator, press calculator for it. We get 10. This is 18 root 6 plus 9 times 2 plus 24 times 3 plus 12 times 6. Like, make sure that your fraction lines cover what's necessary. Don't cover halfway. Okay? You also know where to close halfway, right? Alright, so please make sure your fraction line is long enough, your square root sign is long enough. Okay, so we get 18 plus 12, that is 30 root 6. And then 9 times 2 plus 24 times 3, that is 19. Which simplifies to 3 root 6 plus 9. Okay? That is only r squared. We haven't find L squared yet. Okay? So to find L squared, using this, L squared equals to r squared plus h squared. R squared is 3 root 6 plus 9. No need to square root. No need to square it. Okay, this is already r squared. H squared, this is h. So you must square this one. Okay. So this is r squared. This is h. Right? Then expand and simplify. So apply identity. This will give us 4 root 3 minus 4 root 6. Okay, 4 times 3 plus 4. Okay, plus 4. So 3 minus 4, negative 1, negative 6. 9 plus 4, 21, plus 23. See? 23 minus 6. Okay. Find the values of the integers a and b for which the solution to this is actually square root a plus square root b. Okay? Now what does the question mean? Right? The question says that solution to this is actually square root a plus square root b. Sorry, square root a plus b. What the question is trying to say is that your x, solution of this equation is x. So what they're trying to say is that x is equals to root a plus b. Okay? So essentially you just need to go and find out what is x. Your x will become in this form. Okay? How to find x? That's the big question, right? So let's simplify all the terms first. 24 would actually be 4 times 6. And then root 9 will actually be 4 times root 6. 108 will be 6 root 3. And then 12 will actually be 2 root 3. Okay? So this is what we get. I'll write 2x root 6 here plus 4 root 6 equals to 6 root 3 plus 2x root 3. Right? Then, this is all in root 6. I can write it as 2x plus 4 root 6. Okay? Okay, we should write that. Yes, we should bring all the x to 2x root 6 minus 2x root 3 equals to 6 root 3 minus 4 root 6. Okay? Because my objective is to find out the value of x. So I need to place all the x's on one side. Okay? I can factorize out the x here such that I get 2 root 6 minus 2 root 3 left. Okay? I factorize up. Then this is equals to 6 root 3 minus 4 root 6. Okay? Then I need to find x. So I just divide this over. Okay, then the next step will just be rationalizing. Okay, so I will do that rationalization. You will get square root 2 minus 1. That's your answer. Okay.